Hello everyone, welcome to Mechanical Software Education channel. In this video you are going to learn about the stress analysis of simply supported beam with point load and moment by using Ansys. Look at this drawing. A simply supported beam having a point load of 3 kN and two moments which should be acting on the beam. So one is in clockwise direction of 3 kN meter, and another one is a counterclockwise direction of 1 kN meter. So we can differentiate this one. We can give this point as taken as 1. It is a fixed point, and the moment number 1, we just take the point as 2. The distance between this point number 1 and 2 is taken as 1 meter. So normally while we are giving the dimensions from meter to millimeters in Ansys, so because the cross section for this beam is I section, it is in millimeters. That's why I just convert my dimensions from meter to millimeter. So here in the center, the load which is acting on the beam is point load. We just take the point as 3, and the moment, second moment of 3 kN meter in clockwise direction, it should be taken as 0.4, and the last point should be 5. It is of roller support. So each distance having 1 meter, the entire length of the beam is 4 meter. Okay, so while applying these loads on Ansys, the sign convention is so much important. So here in the point load, it is in a downward direction, so give the sign as negative. And even the moment, so you already know what is moment. It is a measure of turning effect of your force about a point. It is a measure of turning effect of your force about a point. And the sign convention for this moment is also so much important. While you just use clockwise direction, you just give negative sign. While the moment is in a counterclockwise direction, the sign should be positive. It should be very, very important while giving the data or the sign while you entering the inputs in Ansys. And the cross section of this beam is I section, and here the flange width is given as 100 here, and the top region is also 100, and the total distance or the height of the beam is 150. And here the flange thickness is 20. Here it should be also 20, and the web thickness is 10. Okay, so the conversion of this meter to millimeters, it should be given in moment 1 and also moment 2. That is 1 is 6 Newton millimeter for moment number 1, and for moment number 2, 3 is 6 Newton millimeter. So the extra data are the Young's modulus value and the Poisson's ratio. So with the help of these data, we can draw the simply supported beam by using Ansys. Let me move on to Ansys. Here just start with the preferences. Go to structural. In this preprocessor, go to element type, add your element as your beam element 3 node 189, and material properties, go to material model, structural, linear, elastic, isotropic. So 2.1 into 10 to the power of 5, and your Poisson's ratio is 0.27. Give OK and cancel. Go to sections, beam section, common sections. Here you just use I section. So we already discussed that the W1 should be 100. It is a base flange width, and the top flange width is also 100, and the entire height of the I section is 150, and the thickness is 20 flange thickness, and the web thickness is 10. It is T3. So go to preview and check your I section, cross section. You can check with the help of this preview, and go to OK. And now go to modeling, create key points. Inactive coordinate system, select your first key point as origin and your second key point. So each distance having 1 meter, you just convert meter into millimeters, that is 1000 millimeter, give apply. Your third key point, it is 2000, and fourth key point, it should be 3000, and the fifth key point, it should be 4000, and give OK. Now go to lines, straight lines, select the first and second point, second to third, third to fourth, fourth to fifth, and after this you just go to meshing, size controls, manual size, go to lines, all lines. I just divide the lines as 10 division. So here 1 2 3 4 lines was divided as 10 divisions, and now go to meshing. So here you just use meshing and lines, pick all, the entire line was meshed. So each and every line of this beam was divided into 10 equal divisions. So go to plot and check your lines and give numberings for your key points. Okay, 1 2 3 4 5. Now you must give the boundary conditions for this simply supported beam. Go to apply structural displacement on key points. So give first key point, and now check which one is got arrested. So this is a simply supported beam, so the rotation Z should be happens in the beam while applying the load, so all the others should get selected. And now go to the last one, the fifth key point. It is a roller support. So on this roller support you just use UY. The displacement in Y direction must be arrested here, because your moving direction should be in right hand side, it should be in X direction, so your Y should be arrested. Give OK, and now give force moment, and on key points give the center point as your Y direction, so you can check your load, that is minus 3000. It is in a downward direction, minus 3000. Go to apply, and now select the second key point, give OK. It is the moment which should be acting on Z direction, so you can check what's the value. So for moment number 1, it should be if a counterclockwise direction, so it should be positive of 1e6, so that's the value. So 1e6, that's the value. So give apply and select the fourth key point, give OK, and give minus 3e6. So this is the value for a second moment, that is minus e6. So this sign denotes that it just the moment is rotated in a clockwise direction. Okay, now give OK. So now you can check your movements. Okay, now give front view, and now you are going to solve your problem. Go to current load step, give OK, and the solution is done. Now check your result with the help of a general post processor. Go to plot result and check your deform shape first, and now go to contour plot, go to nodal solution, degrees of freedom solution, displacement vector sum, give OK, and check your results. Now go to plot controls, select size and shape and give on. Then only your drawing should be look like a 3-dimensional. You can zoom your drawing, so your eye section was easily visible here. So fit screen, and now we must draw the simply supported beam with moment and also point load with a free body diagram, like shear force drawing and also the bending moment drawing. So with the help of this element table, define table, go to add, you can go to by sequence number, miscellaneous, give 3 and 6 and 16 and 19. Give OK. So this is a sequence number for getting this shear force drawing and also bending moment drawing. So 3:16 is for bending moment and 6:19 is for shear force. Go to close and now go to plot result, counter plot, line element result. Go to this sequence 3:16, you can get the bending moment drawing. So go to front view, you can get the bending moment drawing, and now go to the next sequence number 6:19, you can get the exact shear force. So now if you want to animate this results with the help of deformed results, go to rotation sum, you can check your results with the help of animation. So you can clearly see that the moment, second moment having a maximum value, so compared with the first moment, so that's why the deviation should be larger compared with the first moment. Okay, so now if you want to take printouts for this or save your file, go to style, colors, reverse video. With the help of this one, you can easily capture your image and you can save your image in the bitmap file. Okay, so hope you can enjoy this video. If you really like this video, you just press like and give your valuable comments. See you on the next video. Thank you very much.